Okay, so first position, we are going to consider the same function FC, like we have in bisection. Okay, but this time we are going to use first position method, not bisection. We are going to make use also previous information that we have. Okay, like this table. So in the first position, we are going to start with a suitable interval. Okay, so the interval must be the interval containing the roots. Okay, so we know this, the true value is 14.7802. Okay, so 14.7802 is lies between this 12 and 16. Okay, so that's why we choose this interval. You can choose others interval also. Maybe you can use 12, 15. Or else you can use 13, 15. You can have that condition also. Okay, by this time, I just want to show using one of this interval, 12, 16. Okay, so this is the general formula. So we start the numerical table. First column is your A, second column is your FA, next column is your B, and then FB, and followed by column C. So A, FA, B, FB, C is everything in the formula. Okay. Okay, so we start with the interval 12, 16. 12, 16. Okay, and then find out what is the value of F12. Okay. Okay, F12, you can get the information that we have. F12 is 6.067. F16 is 1, negative 2.269. Okay, so we write down the numbers in this table. Okay, so we calculate the first value of C using this formula. Okay, so we have B. So your B is 16. So write down here. And then minus FB. So FB we have negative 2.269 times A minus B. So we have 12 minus 16. Okay, so like this. And then divided by FA minus FB. Okay, so we have this number. Okay, could you please calculate for me what is the value correct to, let's say we consider 3 decimal places in this table. There's a value.
Pinpoint 911.
911. Okay. Uh, any other students didn't get this number? You get the same number? Okay. Okay, so let's look at the interval for the next calculation, next iteration. Okay, so we have look at the interval. So new value of C is 14.911. Okay, so we're going to sort between the smallest to largest. 12. Then the C will be your new value, B. Okay. So new interval in the calculation that we're going to use will be new B. Okay, FA, because there's no changes on A value, so we are going to use the same number. Okay, for this B, you need to calculate new value. Okay, what is the value of F14.911? Okay, how to evaluate? Refer back to your FC. This is your FC. Okay, you are supposed to replace the C with your 14.911. Okay, replace 14.91. So here will be also replaced by 14.911. Okay, refer to this function. Okay, so after you substitute, you are supposed to get this number. Okay, so if you want to calculate, maybe you can try. Here, replace 14.911. So this one, 14. So simplify. Use your calculator, simplify. Okay? Can you verify? Is it you're getting same number? Okay, did you get this negative 0.254? You get or not? Okay, you get or not? No response. Can you just talk because I don't want to minimize the screen?
Dapat Eden.
Dapat. Okay, so calculate new value C. Still use this formula. Okay, so we have B. Okay, minus negative 0.254 times 12 minus 14.911. Okay, then divide by 6.067 minus negative 0.254. mm, Okay, is Ziad online? Ziad, can you give me the number? Final number here.
Calculating, madam.
Okay, I'm waiting.
14.7940, madam.
Correct to 3 decimal places.
14.794.
Okay, thank you, Ziad. Let's see. Okay, I'm going to add several columns here. Let's see column for this absolute error. Okay, so like superscript, subscript. Okay, hope that you still remember the formulation to calculate the absolute error. The first row will be empty. Okay, because in the absolute error, we calculate using current value with previous value. Okay, but in the first calculation, we don't have previous value because we just started the calculation. So the absolute error for the first row will be empty. Okay, so we start calculate this on the second row. Okay, here calculation for the absolute error is 14.794 minus 14.911. You should write down what is the general formula, okay? You may refer to the formula that I have written on the e-learning. I have posted that. It is current approximation minus previous approximation divided by current approximation. Then we have absolute. Okay, and then times 100%. Okay, so this is a step. Okay, this value you can copy because I'm going to delete this number. You can copy this green one. Okay, so I will delete this one. Okay, so the number that you get here, it will be 0.79. Yeah, it's okay if we, for this absolute error, okay, maybe the absolute error or relative error, you can choose 2 decimal places, but in the calculation, in terms of ABC and also FA, FB, okay, make sure round off correct to 3 decimal places. Okay, so this absolute error is 0.79%. Okay, in the FC that we have in the bisection, the estimated error is given value as 0.5%. Okay, so do you still remember what is the stopping criteria for bisection? Bisection, what is the stopping criteria to stop the calculation? When the absolute error is less than estimated error. Okay, we are going to have the same reason in this first position. We stop this calculation in this table, in the first position table, when your absolute error is less than estimated error. Okay, so this is the stopping criteria. Okay, so we have 0.79. Are we getting less than? Or it is less, it is bigger than? Less or bigger?
Bigger.
Bigger.
Bigger than. Okay, so it's not less than. So bigger than, so you still need to continue the calculation. Okay, so calculate. Okay, so next value we have 12. Small to larger one. Okay, so C. This will be your 14.794. Okay, so similarly, we calculate this one same number. Calculate for this value. Here will be getting negative 0.027. Okay, you get this here by substitute what? This value 14.794 into this function, into this FC. Okay, so next step is using the same formula for this first position. We have this one 14.794 minus negative 0.027 times 12 minus 14.794 divided by 6.067 minus okay, Saiful ada Saiful? Saiful?
Ya saya.
Boleh bagi saya nilai.
Okey, kejap
Tekan calculator. Okay, Saiful. Dah dapat belum? Tak dapat tekan? Belum lagi?
14.782.
Okay, thank you. Ganesh Kumar. Ganesh Kumar.
Cari calculator dulu.
Ganesh Kumar.
Yes, madam.
Okay. Dapat 781. 782 right? Seven 14.782. Okay, Ganesh Kumar. Could you please give me the percentage for this absolute error? Absolute error here. Ganesh, do you hear my question?
Yes, madam.
Okay. So the absolute error will be this number minus this one. Okay. Divide by this number, absolute value, and then times 100%. So just give me what's this percentage here.
Madam.
Hmm.
Minus with which number, madam?
This number, you still tak tahu lagi macam mana kira ke? Current value, current approximation value minus previous. This is previous. Divide by current. Where's the number? I know why it take you long to calculate. Ganesh, you get or not? Ganesh?
Madam, 0.8.
Huh? Where you get 0.8? You calculate by yourself or you get answer from your friend? How come you get 0.8? Ganesh? How come you get 0.8? Can you respond, Ganesh? Which number that you got?
Madam, I minus the 14.782
Yeah, and then times
minus
100%. How come you get 0.8? It's not 0.8. Anyone get the percentage here?
0.08.
0.08. Ganesh, You tahu tak macam mana dapat 0.08 ni? This number minus this one divided by this times 100%. Okay. Need to consider positive So negative sign tu kita akan remove.
Kiranya
Okay.
negatif tu tolak tepi lah.
Formula dekat absolute ni absolute symbol. Meaning of absolute ni kita take only positive value. So this number minus this number negative kan? Negative number, right? Tapi general formula for absolute error ni ada symbol absolute. Absolute ni maksud dia kalau you dapat negatif kena ambil positive value sahaja. Okay, so kena tulislah this absolute symbol ataupun modular symbol. It's the meaning dia. Okay, that's the meaning for the absolute or the modular symbol. When you calculate the absolute error and relative error, you should not get negative, okay? Because in the general formula there is modulus or absolute symbol. Okay, Ganesh, dapat tak 0.08? So still, ataupun you still dapat 0.8%?
I get ready, madam.
Okay. Okay, let's see. The absolute error 0.08. Okay, so still bigger than the estimated error. Okay, still bigger than. So we still need to continue the iteration. So here we have 12 and here is 14.7802. Okay, so it will be the same thing. Yep. So,
lagi kecil ke dia?
tak dengar apa dia?
Bukan dah lagi kecil ke dia?
Besar lah.
0.5 dengan 0.08.
Kejap. Saya tersilap tulis kejap 0.5 ke 0.05? Kejap. 0.5. Okay, sorry. 0.5. Okay, sorry. So stop lah. Saya tertengok 0.05 pula. Nah, 0.5. Okay, so stop. So we stop this iteration. Okay. Sorry, this one. Okay, so here we have that the absolute error less than estimated error. So we stop the calculation. Okay, so in this first position, we have to stop at this, the third calculation, 14.782. Okay, let's see. Okay, in bisection, so this time we are going to compare bisection. Bisection answer is approximation value using bisection is 14.8125. 14.8125, okay. So using bisection, we have the approximation value. AV means approximation value 14.8125. Okay, so using first position, we have approximation value as this one, 14.782. Okay, so this one, if we want to compare which approximation value is converging to the true value, okay, or we call it more closer to the true value, one of the method you can calculate by evaluating the relative error. Okay, so relative error symbol, I'm showing this value in the table. relative error is epsilon t. So it should be in the percentage value. Okay, so the first iteration we have this number, true value. So true value is 14.7802 minus current approximation value with this number. Divide by true value. Then times 100%. Okay. So here you'll get 0.88. In percentage. So everything here is in percentage. Okay, so do it similarly for the second and the third number. For the second one, can someone give me the percentage of relative error? Naufal ada? Naufal?
Ada, madam.
Boleh bagi saya final number kat sini, percentage value.
Kejap.
Okay, calculation at the second row. For true value is 14.7802 minus 14.794. Okay, divide by true value and then times 100%. So same thing. Taking only positive value. Dapat tak Nabil? Tahu berapa ni? Nabil? Tak dengar. Berapa?
0.09.
0.09. Betul ni? 0.09.
Saya calculator tempat tu.
Zero nine.
09.
Yes, number. Okay, Vira, the last percentage here. Is Vira online? Vira? No Vira
0.01.
Oh, Zahir jawab. Okay, jap. Oh, Vira ada tapi tak ada respons. So here 0.01%. Okay. So then let's compare. Okay, this percentage of relative error for first position, we have 0.01%. Okay, the percentage of relative error using bisection. We say bisection. We have the table that day with the percentage. Okay, this one 0.2%. Okay, 0.2%. Oh, sorry. Okay, 0.2%. Okay, so how we compare? Smaller percentage of relative error will give us the approximation value that more closer to the true value. Okay, so the meaning here is when you have smaller percentage of relative error, the approximation value is closer to the true value. Okay, so we can see in the bisection we have 0.2%. This is value is bigger. The percentage of relative error in this bisection method is bigger than the one in first position. Okay, so we can see that approximation value using first position, okay, converge faster. Okay, or we can say it closer to your true value. Okay, so means that first position approximation value lagi dekat dengan true value or exact value. Okay, if we compare based on the number of iteration, okay, in this first position, we just calculate for 3 times. Okay, you can see there is 3 rows, right? Okay, in the bisection, we have to calculate, right? 1, 2, 3, 4, 5, 6. Okay, 6 iteration, but in the first position, we have 3 iterations. Okay, 3 iterations. So what we can conclude, first position method converge faster to the true value compared to the bisection. Okay, so there will be a similar question that will be given during assessment, something like that. Compare which method is better, okay, or conclude about the converging. Okay, any question? Some question that you want to ask? Okay, remark here, I did mention last class, for this true value, this true value in this problem given, it's in 4 decimal places. Okay, even in this table, we calculate 3 decimal places. Your true value, you cannot round off. Whatever number of decimal places, okay, you should use all for true value. So let's say if you want to calculate for the percentage of relative error, use all numbers, use all digits. Do not round off. Okay, means that you cannot round down or round up. So don't round off. So if you are given, let's say, 7 decimal places for the true value, you are supposed to write down all 7 decimal places here. Okay, so do not round off. It is invalid method for this percentage of relative error. So whatever numbers given for the true value or as exact value, okay, use all digits. Okay, so the one that I means regarding the calculation correct to 3 decimal places is the one in this column. Okay, not for calculating the percentage of relative error. Ada tak soalan yang tak bagi true value? Okay, Nabil ask questions. Is there any question that doesn't give what exact or true value? Yes, there's a question. So you need to find out. Okay, so one way is to find out is you let the function equal to 0 and then solve for the unknown variable. Okay, let the function equal to 0, solve for unknown variable. So this topic, if you want to find out the true value, you cannot get from the calculator. So if it's not given, then you need to find out. Okay? Okay, any other question?
January tu subject sub to 0 eh.
Contoh. Contoh. Okay, contoh apa Sekejap contoh apa? Sekejap, saya cari function lain. Okay, so let's say your function gx is x squared minus 4. Let's say something like this, very simple. I'm choosing very simple function. Okay, so let's say you want to use bisection or maybe in fourth position, right? Okay, so you just have this function. There's no interval given, so you didn't know what is interval to start in the calculation, either in bisection or fourth position. So you should know the true value first. Okay, so to get the true value, okay, you let this gx equal to 0. Okay, so you have x squared minus 4 equals 0. So x squared is 4. What is the root?
2 madam.
Huh? Is the root?
2 madam.
Huh?
2.
2 plus minus 2 kan? Correct. Okay. Let's say they ask you to consider maybe the interval. Sorry, not interval. The roots. Okay, that is negative root. Consider negative roots. Let's say they can mention like that lah, negative roots or maybe positive root. Okay, so if you have negative root, so your true value in terms of negative root is negative 2. Okay? Okay, so what is your interval if you have this? What is your interval? Suitable interval. Your true value is negative 2. So what is the suitable interval?
Negative 3, negative 1.
Negative 3, negative 1. Okay, negative 3, negative 1. This is your A, B. You can choose other suitable one because the middle one, negative 2, is lies between, right? Okay, if you have, let's say, positive root. Root means the solution lah for the function. Okay, so if positive root, so your true value is positive 2. So if your true value is 2, so what is the suitable interval?
1 and 3.
1 and 3. Can we have 1.5, 2.5? Can we have this interval?
Okay, masukkan. Yes,
Boleh
madam.
guna tak this interval?
Boleh madam.
Boleh. So you can have this interval, you can have this interval. Depends on which root that you consider as true value. Okay? If your true value, let's say true value here is -2. Okay, let's say true value is -2. Okay, so can you choose, let's say 1, 2 in the interval? Let's say true value as negative root is -2. Can we choose this interval?
Cannot, madam.
We cannot choose. What is the reason? This one cannot.
Positif.
Because
Jauh. So value
Buat
is
positif.
negative.
jauh apa?
Jauh dari nilai betul dia.
Jauh dari nilai, salah. I did mention, I did include this kind of question in the assessment. But
Sebabnya
I
kita
think
contoh tak dekat tengah-tengah.
sebab tengah-tengah. Bahasa Melayu macam mana? Bahasa Inggeris macam mana nak jawab? Because you are going to write down statement as the reason.
Because it is not in between the apa benda tu, approximation.
Mana pula approximation? Tak ada dah approximation. Approximation value is the one yang you calculate. The one that you calculate using the method, special method tu we call approximation value. Okay, can someone state the reason? Selalu reason ni memang student tak boleh jawab lah. Sebab student selalu tahu kira je. Tapi untuk reason, you should know how to state the reason. Justify lah, justify. Why we cannot choose this interval?
Because because the value is not near to the true value.
Not not near. Ya ke near? Tiba-tiba near pula ni. So wrong reason. Then next. Next try.
Because the root
Because the root. Mana root ni?
yang 1, 2 tu kan. 1, 2 tu root kan.
Ni bukan root. Root kat sini. This is root.
1, 2 tu root.
This is root. Okay.
The value is not between -2, madam.
Okay. So buat ayat. Buat ayat lengkap. Full statement please.
The value must be less or bigger than the value.
Bigger pula. We
Value.
cannot use 1, 2. Okay. Okay, as the starting interval. In see name of the method lah, okay. In this case, bisection or first position. Okay, can say since or because what? This one you just put name lah. This name bukan semua method lah. Name of the method, not all method you boleh tulis but it is related to the method that having these kinds of situation such as bisection, force position. Later on you have other method, let's say fixed point iteration, Newton-Raphson. So that kind of method you can have these kinds of reason because that method use different one. Okay, so you can see here we cannot use this interval 1, 2 as the starting interval in the bisection method. Okay, or it can be as the starting interval in first position method since or because what? Okay, what is the reason here? Next one. Since what? Come on guys, apa? Sebab apa? What is the reason here?
Since the value is not in between the true value.
Between. Hampir-hampir lah, sikit-sikit lagi. Since you cannot say close to, itu salah, not close. The reason is not because of close to.
Since the true value is not in the range of the starting interval.
since -2, okay, this true value. Okay, either you write down true value or you write down the number of that true value. Since -2 does not lies in the interval. Okay, the interval is 1, 2 lah. Okay, another way you can say since since the interval 1, 2, okay, does not contain the roots of -2. It has the same meaning. Okay, so I'll repeat. Since the interval 1, 2 does not contain the roots of -2. This example, if for negative root, kalau you have positive root, so there will be a different form here. So this should be 2. Okay, so there will be change on that. Depends on your roots. What kinds of the number? Okay, question? Do you have question?
No, Madam.
Yeah.
No, Madam.
Okay. So this one saya padam because soalan ni saya nak tanya nanti.